Hi guys, welcome to this video. In this video, we are going to assemble the linear actuator using Creo parametric. So let's get started. So first of all, let me explain like how to download and access the part which I am sharing on the drive link. Okay, so some of them are having the issue to download the parts. Okay, so if you have if you have experience on downloading those parts, you can skip this. Okay, so first of all, let me go for our channel homepage. So here you will see the pinned video. So this is members only content. So here you have to purchase the membership so that you can able to view this video. So at the end of this video, there's a password for the drive link. Okay, so here you will see the 3D model link. So this 3D model link will be available on this video description also. You can access over there also. Okay, so when you click on the 3D model link, like here you can see a Google form is opening. So here you have to fill the password. The password is on the end of this video. Okay, so final 5 seconds you have to watch that. Okay, so at the end that's a password. So once you enter the password, you will get the drive link and you can get into this page. So here you can see you can access all the parts by joining as a 29 rupees of basic membership. So once you purchase the 29 rupees of membership, you can download and access all these parts here. Okay, so I hope you have checked my channel homepage for a better explanation. Okay, so here we have a linear actuator. So directly download this folder. Okay, so don't get into this folder and don't try to download individual parts and assemblies by separately. Okay, so the file may get some sort of a collapse. Okay, so if you download this as a zip file, you can see the zip file has been downloaded. Okay, so I think this web page is done. Okay, good. So now let's go for the Creo, open, and let's go for the downloads. And either you can extract the file from the zip or else you can directly use the zip file also, because Creo can access the zip folders. Okay, so here we have the final assembly. Okay, so on the message dialog box you can see nothing is there. So here we don't have any missed parts. So this is our assembly. Okay, so in this video we are going to assemble this entire parts and all these dimensions for the parts. Okay, and everything will be uploaded on a part wise daily. So this video is only for the assembly. Okay, so you can download the parts by using this method and you can assemble all these things like if you follow this video. Okay, so all these parts like slider, thread rod, and frame 1, frame 2, like end plate, servo motor, so all the parts will be uploaded separately as a part 1, part 2, part 3, part 4 on a daily basis on from tomorrow. Okay, so yep, so let's go and start the assembly. So first of all, let me close this and let's erase. Okay, so let's click on new and let it be the assembly, and here let me name it as linear actuator. Okay, so then MMNS design ABS. Good. So now at first I'm just going to make our base part as a default constraint. So let me go for the assemble, and let me check whether this is on the downloads, linear actuator. So here from all these parts we are going to assemble. Okay, so not on my working directory, on the downloaded folder. Okay, so let me go for the preview. So this is going to be our base part. Open it, and this is going to be the default position, and done. Okay, so the next part that we are going to assemble here is frame 1. Okay, so let me go for the frame 1 and open it. So now we are going to assemble this here. So this is fully on user defined constraint because this is fully of nut and bolt assembly, so no need for any other mechanisms here. So we can directly use the user defined function. Okay, so z and x has fixed and this is a y-axis constraint. So now our part is fully constrained. Make sure whether this holds or like coincident with each other. Okay, yep. Okay, done. So now our next part will be frame 2. So this is our frame 2 and this will be also same as user defined. So let me just grab it up And let me check whether we have. So here you see a small cut is there. This is for the guide rod. So for the guide rod, it should be on the inside. So make like we have to verify whether we have done the same. Yep, good. So now let's select the outer surface. Oops, sorry, this is not outer surface. So this inner surface and this inner surface. Make this as a coincident. Sorry, coincident. And this face and this face, make it as a coincident. And on the bottom, we have the bottom surface and this bottom surface as a coincident. So now you see we have placed the two parts. So make sure your like this small extruded surface should be on the inside. Okay, so this is for placing our like a slider rod. Okay, so two supporting slider rod. So next part we are going to place that slider rod. So let me just go for the assembly. And where is the slider rod? Yep, this is the one. So this one I'm just directly going to use user defined because this does not have any motion. So let me just turn off everything except the axis, and this face and this face. And done. So now once you see, this part can't be moved because this is fully constrained. Okay. So when we use pin mechanism for this, it can able to rotate. Okay, so it may broke our mechanism. So I'm just going to use the user defined function. So I'm just going to repeat the slider rod one more time. Either you can use repeat option for that. Okay, so I'm just going to do one more time. Same again. Okay, so two slider rod are getting placed. So now here I'm just going to create a bearing because the thread rod will be a very small rod when compared to this hole. So I'm just going to use a bearing for a smooth rotation. So let's go for the assemble, and here we have a bearing. So let's turn on the planes at first. Okay, I'm just going to, yep, like normal function, not a pin mechanism. Okay, so this one is axis, right? Bearing axis. Okay, so this frame one axis, make it as a coincident. And now for the plane coincident, I'm just going to select the frame one front and bearing front and make it as a coincident. Okay, so now you see we have placed our part. So let's click on OK. So one bearing is done. So on the other hand, we have to do one more bearing for our thread rod, but here we don't like fix our thread rod. So for fixing our thread rod, we have to create an end plate. So let's assemble the end plate here. So where is our end plate? Yep, here. So this end plate, this is not going to be a moving part. So I'm just going to assemble this as a user defined function. So for the user defined, first of all, let me select the ground, this bottom and this bottom, coincident. Okay, so on the next here we have to coincident with this circular thing. So let me just or else we have a distance coincident here. So this one and this one. So here the distance will be 300. Okay, so this outer and this inner surface. Okay, so this is 300. Yep, right. So now I have one more thing here for the new constraint. So either you can use cylinder or else cylinder will get some motion. So I can go with this one. This is coincident. Okay, so now our part can't be moved. So it is fully constrained. So now we can click on OK and you see our part is fully placed here, right? Okay, good. So now here we are going to place our thread rod. So for here I'm just going to place one more bearing here. Okay, on the same user defined function, axis, and this one axis, make it as a coincident, drag it here, and the same here I'm just going to use the plane constraint. So as a plane, okay, so this mid plane and this mid plane and make it as a coincident. Okay, so done. So the next thing is like we are going to place our thread rod. So let's open the assemble, and here we have our thread rod. And make sure like when you are assembling, like assemble the thread rod, so the long part should be on this place. So because we have to attach a coupling with the servo motor. Okay, so the small part should be on the other side. Okay, so this is going to be the pin mechanism as this is going to rotate. Okay, so here let me select the axis of the end plate and the axis of the thread rod. Okay, so then for the translation, let me drag it here, this surface and this end surface. So now I think everything is placed perfectly. Okay, so now let's click on OK. So once we have placed our thread rod, we can directly bring our slider inside of this assembly. Okay, so here I'm just going to assemble the next part. So that is going to be our preview slider. Okay, so when while you are assembling this slider, make sure your point is towards this direction. Okay, so because we have to create slot mechanism here. Okay, make sure your point visible here. Okay, let me just hide everything to have a good view. Now you see a point is here. Okay, so this point will be created on this thread. Okay, for the slot mechanism. So you will get to know once this part making video will be released. Okay, so on that video you can able to have a good definition over there. So this point should be on this end, like frame one direction. Okay, so now here I'm just going to make a cylinder constraint, so it will be very easy for us. So I'm just going to select this axis and this axis. Okay, so let me just drag it here. Okay, and what's that, one more cylinder, right, for this axis and slider axis. Okay, done. So two axis constraint is done. So we can see our part is fully moving like this. So what else we have to do is we have to make the slot mechanism here. So new set. So this is not going to be a cylinder, this is going to be a slot. So for this slot, okay, our point is located on the okay, so wait, one more, like 1 second guys, let me explain that. Let it be like this. Okay, so let me open the part. Okay, so hide everything except the point. Okay, so now you see our point is created on this particular thread. Okay, so here we have two threads. So here we have one more thread in here. Okay, so this is created on the right side. So our point is placed on the right side of the thread. So when we go for the sectional view, you will have a better angle over there. Okay, so yeah, here you will see in this cutout, it looks like a slanted rectangle, right? So here we have see like a triangle feature here. So here you see this is the curve where we placed our point. So this curve belongs to the top right side of the smallest part. Okay, so in the assembly, in the thread rod, we have to select the same small top right side of the curve. Okay, so I think you guys have understood. So this is the profile of our thread rod. Okay, so there will be extruder. Here we have a extrude cut. Okay, so the right side of this, like right side of this line, we have to select on the slot mechanism. Okay, so here let me go for that, and here we have a new set, and I'm just going to make it as a slot. So when you zoom here, like I said, this is our top face, this is our left, and this is our right. So this is what I said on the right side. Okay, so make sure like you are selecting the continuity of the previous line. So this is our line stopped, right? So we have to select from there and from here and from here, here. So make sure like you are selecting the same curve. Okay, so like you see for this here, here is a curve and here is a curve. So this is our continuity. So make sure you are selecting the exact curve. Okay, so yep, so selecting inside the part is very complicated. Okay, and yeah, try to zoom as you can. Okay, so that it will be very easy. Okay, so I think this is the last. Okay, we have one more. Done. So this is our end, right? Yeah, we have reached our end. So after selecting all these curves, we have to select the point. So done. Okay, so our connection definition is completed. So let's click on OK. Okay, so whether I clicked OK or cancel. Okay, I thought I clicked on cancel. Okay, good. So let me go for the drag and let's look whether this is working. So now you see our part is moving really good. Okay, so the one thing that most of them will do mistake on this assembly is, so whenever you use slot mechanism, don't use drag as much as you can. Okay, so don't use drag components option. If you use, you can directly, like suddenly you have to regenerate it, or else sometimes the mechanism may broke when you use servo motors. Okay, so this is the issue most of them are reaching me. So they have got these kind of issues. So don't use drag. Like you see, I have used drag right now. Suddenly I just click on regenerate option. Once you click on regenerate until your part has stopped moving. Okay, so done. So we have done our slot. So what's next? So here you can see we have a gaps here. So we have to connect this two, right? So end plate is fully directly placed on the part, but we don't have any screws here. So for that, let's go for the screws. Okay, so let's go for the pin. Let's have a axis. Okay, so this axis. Okay, this axis. Come back. This surface and this surface. So it is fully placed. So now once we have done a single part, we can directly go for the repeat option to make it easier. Axis, surface, add. So this axis, the surface, this axis, surface, axis and surface. Okay, done. So same on the back. Okay, where is the axis? Okay, good. One more axis. See why this line is got selected. Okay, done. So we have placed enough screws. So one more screws we have to place on the servo motors. That's fine. And okay, on the coupling, done. Okay, done. So 4 screws and 4 screws. Okay, good. So now it's time to place our servo motor here. So here we have a big cutout here. So where we have to place our servo motors. So where we have our servo, yeah, we have a motor. Good. So let's flip it towards backside. So let it be user defined. Select the surface and make it as a coincident. And here, okay, fully getting collapsed. Okay, I need this particular center axis and this particular center axis and make it as a coincident. Okay, so it is fully constrained, right? So if we have any more issues, let me check it with the circle. Okay, good, fully constrained. So we have placed our servo motors. Okay, so then like connecting these two, like servo and this thread rod, what is going to connect these two? So this is coupling. So that is our coupling. So yeah, here we have our coupling. So for the coupling, definitely we should use our spin mechanism. Because that's going to be a rotating part. It should have a rotational axis. So select both axes, and here I'm just going to select the end surface of this thread rod. Okay, so let me check it. Yep, end surface of the thread rod. And okay, so here I'm just going to, where's the plane? Okay, good. Oh my god, fully collapsed. Let me just move it outside. Okay, so on the end surface with the front plane of the coupling. I don't know whether that's a front plane. Yeah, that's a front plane of the coupling. So it will got fully placed, right? So that's the midpoint. Okay, good. So we have done this. So the next thing is we have to attach screws here and screws here. So for that, either we can go for repeat or else, okay, so let me just assemble the screw for one more time. Same pin. Okay, everything except the axis. Okay, this axis and this face, and oh my god, it's got a fully inverted. Okay, so flip it, pin, axis, axis, and surface and surface. Okay, so now we can easily use our repeat option. So either you can use before also, but I'm just doing one more time for our reference. Okay, so add it, axis, surface, axis, surface, and here we have axis and surface. So that's fine. So same on the servos, the motor, and axis, surface, axis and surface, axis, surface, and axis and surface. Okay, so yep, I think fully constrained, right? So let me check one more time. So yep, so everything is done, guys, but we have like not noticed this part. So when you move our slider, so it may get outside of the part. Okay, so let me just go for the edit section. So here you see our slider haven't placed on a single position. You see it's getting outside of the path. So we have to create a translation axis. So let's select this surface and this surface. Okay, so I'm just going to place the current position as 0 and enable the minimum and maximum limit. And so this is going to be negative value. So maximum limit is 0, and for the minimum limit, so we have to measure it by ourselves. Okay, so I forgot the value that I have noted. I think 1.5 something. Okay, so here we have some gap, so minus 1520. Yep, that's getting an exact location, right? So 1519, yeah, we have a gap. So minus 1520 is the exact value for this. So minus 1520. Done. Click on OK. Okay, so what we have done is like we have to create this before placing our thread rod, before making our slot axis. So no problem. Let's try regenerating it. Yep, done. So like we have to do this before the slot mechanism, but okay, you can do this right now also. Okay, so let me check it with this one more time. Okay, let's disable everything. Okay guys, it's working, right? So do that before itself. Okay, so Don't use much drag like I said before. Okay, good. So now we have placed our part. So everything is done, right? So we can directly go for the servo motors. So application mechanism, servo motors. So here you see the servo motor is a basic problem for everyone because you see multiple of pin joints here. So either you can choose, so I'm just going to choose this pin. If you are confused with that, if you have multiples of pin joints, but if you want to place servo on a single joint, okay, so what am I recommending is, so this is where I'm just going to place my pin. Okay, so if you are going to use pin mechanism here, so directly set the connection name as servo, the servo or servo joint or anything. Okay, so when you get into the application mechanism, so right now everything is highlighting, that's fine. When you get into the connections joints, so here you see everything is on connection but except the servo. So this is the servo joint where we have to connect our motor. So inside this you see a rotational axis. So here we have a servo motor. So done. So that will be our angular velocity and the rotation is 30 degrees per second. So that's our coefficient value. And okay, everything is done. So let's check the direction of the motor. That's right, but it is going towards back side. Okay, so then we'll try one more case. Okay, so okay, I recommend you guys not to use much drag, but I'm using right now. Okay, so let it be on the top end position and let us run the part. Okay. Okay, so okay, done. So that's fine. Not to the except like not to the up to end position. Let us regenerate. That's fine. So hide everything. Application mechanism analysis, and here we have an end time of okay 200. Let us check 200 and frame rate. Let us make somewhat speed. Okay, so oh my god, oh okay, sorry guys, I forgot to flip the motor. So that's the reason why I bring the slider from here to there. Sorry, so I have to flip that. Okay, done. Mechanism analysis. So here we'll go with the 200 and frame rate with the value of 6 and run it. Okay, so that's all guys. As you can see, our part is running successfully. Okay, so thank you guys. So thanks for watching, and if you want more videos related mechanical engineering or any other content, you can comment below so that I will upload more and more videos based on that. Okay, so thank you guys. We will see the next video with a very interesting content. Until then, bye.